Welcome to the session on transforming code to Java 8. What I'm going to do here is talk just a little bit about some reasons to do it, and then I'm going to take some examples. We are about an hour, so my goal is not to do everything, but to do as much as we can in an hour. So we'll keep plowing through as much as we can for the time we have on our hand. One of the biggest changes in Java 8 is we are going away from imperative style to a functional style of programming. Now, learning a syntax is easy. Learning a library is easy. Making a shift to a different paradigm is usually very difficult. With Java 8, it's a paradigm shift more than a syntactical difference. Third row, I see an empty seat. The person walking towards us, come to the third row from the front. Is there anything other seats available? I think that's all we have. There is actually a seat available here too. This is a first class seat if you want to take it. It's here. Who wants to take it? You want to come here? I'm not kidding, you can. There's nothing wrong. Absolutely. You're welcome to use that seat. Okay, so we're moving to a functional style of programming, right? All right, there's a brave person there. Come on up. Awesome. There you go.
Thank you, sir.
Awesome.
Thank you, sir.
Please. So, we have the functional style. Changing the paradigm is more difficult, right? It takes a lot more effort to change paradigms. That takes quite a bit of effort. And I got a little secret for you. If you want to come up here, I see 3 more chairs over here. And you're most welcome to come and take it. I don't have a problem with that. So I'm not making up. There's actually chairs. Okay, so what is functional style? We write declarative code. That's the very first thing we do, right? We are writing declarative code. That's the first thing. What does that mean to declarative code? You tell what to do rather than focusing on how to do it. That's the first thing you do. Second, it's a higher order function. You are able to send functions to functions rather than only passing objects. You're honoring immutability as much as you can. You're writing pure functions. Why should you do all of that? First reason is you write concise code. Well, what is concise code? Concise code is smaller amount of code that is very easy to understand, very easy to work with. It's also expressive, so you can easily read, you can easily explain what you're doing, you get it very quickly. You write less code. You may say, wait a minute, less code, doesn't less code mean concise? I want you to think of 2 terms, concise and the word terse. Both of them are less code. Concise code is transparent, easy to understand. Terse, short and waiting to hurt you when you least expect. You want the code to be concise, not terse. The code is easy to understand once we understand the syntax. It's easier to modify the code, has fewer bugs in it, almost easy to parallelize. These are some of the benefits. Enough talking, let's get to work. The first thing is, let's take a look at an example of a code. What does this code do? It has an executor service, creates a new executor service, loops through values 0 through 9, and you can see, I got an index equals to I, make a copy, and I call the submit button, submit method, pass a runnable to it. The run method, I call print line, which says running task, and then of course I say task started, shut down the service afterwards. Run the code, let's see what it does. You can see that it produced the output. This is a very common code you all have seen before, right? You're familiar with this code. Nothing really unusual about it. So that's the code, and that's the code we have with us. But there's a lot of noise in this code. The first thing about Java 8 is, it's got what's called a functional interface. A functional interface is an interface with one abstract method in it. Not 0, not 2 or more, just 1. As long as you can have one abstract method, automatically it becomes what's called a functional interface. Anywhere a functional interface is expected, you can either send an anonymous inner class, or you can send a lambda expression. Let's go back to this code and look at a few things we can do differently. The very first thing that I'm seeing here is the word final. Can somebody tell me why we have the final here? I hear a murmur, but I'll give you one answer. The final is here because if I don't put final, the Java compiler threatens to come and burn my village. So I got to put the final, right? Otherwise the compiler gets very angry. Besides that, why do we need to put the word final? It's a why should we, what is special about being anonymous in our class? I heard the word stack. Did somebody say the stack? Yeah, so what about stack?
So each thread will maintain its stack space.
Yeah.
There if it gets modified.
Almost there. Why?
The value of index should not change inside.
Why shouldn't it change? What's wrong with it?
We are using it to inside the thread.
Yes. So
in order to keep the value inside the thread unique.
Why should I keep it unique?
For local variables, we can always ensure that they will never be used by any other thread at all.
Why?
Because every member thread gets its own memory space for that variable. Like if you have int I in a method, it's a local variable. Every thread will get its own copy of int I.
Why should it get a copy of its own variable? Why should it do that?
Only that the instance can.
A little louder, please.
Only that the instance can be observed, can be shut down.
We're all kind of going around it, right? What was it? A little louder. You speak really loud. I'm deaf.
Because of the scope.
Scope? No. So here's the deal. You got an anonymous inner class. You come into this function main, which is the stack, right? That's why I said, hey, somebody said stack. That's a stack of the main function. What is this variable called I? The index. Index is on the stack. So here it is on the stack. You create an anonymous inner class. Think of this like a balloon. You create this little balloon, it floats away, and as this is floating away, what's going to happen to the stack most likely? Disappear, right? The lifetime of the anonymous inner class is long-lived potentially compared to the stack where it was created. Does that make sense? What will happen if I get created here and I depend on a variable which is going to just go away? I'm in trouble, isn't it? So what do? Well, obviously you don't want that variable to disappear, because if that variable disappears, I'm kind of left hanging here, like I variable to go, right? So here's a way to fix that. Let's make a copy of that variable, right? You all said the answer, but in bits and pieces. One person said that, somebody said it's the elephant's tail, somebody said it's the elephant's, trunk. Got to put together that whole thing, right? So here's the stack, here's the data on the stack. You create a little balloon, the stack disappears. Oh boy, that's a problem. Let's make a copy of this here. Oh, now it doesn't matter the stack disappears because I've got a copy. Wonderful, isn't it? But there's one problem when you make a copy. When you make a copy, what if somebody goes and changes the original? Now we are confused. Did you get the value before the change, or did you get the value after the change? Who wants to be doing that debugging? Nobody, right? Because you're not sure when the value actually changed. Before the time you made the copy, or after the time you made the copy, or while you're making the copy. Hey, they said there's a way to make this doesn't happen. Let's make it immutable. If you make it immutable, your copy, you can make it anytime you want to, and as long as you have a copy and the original doesn't change, you are safe. So the reason for final is to preserve the copy semantics. That's the reason for final. Well, now that we understand that, if you don't put final, the Java compiler will give you an error. But that's true for Java 7. Java 8, I did not put final, and notice it doesn't have a problem. Hey, what's going on here? Well, the Java 8 compiler says, you know what? You and I have been going out for 20 years. We can develop some trust between each other, right? And so the Java compiler says, as long as you behave properly, we don't need this convention of final. So as a result, this is called effectively final. Notice it doesn't have a problem with it. But if I quietly sneak up here and say index equals something, immediately Java says, I thought we had an understanding between us, right? And doesn't want you to do that. It says, now go back and put final, right? So it is a mutual trust, right? As long as you behave properly, you don't have to really say those things. So that's called effectively final. So we got rid of the final after all. Great. But what about this code? Notice in here we say new runnable, void run, that is called ceremony. That's a lot of ceremony, right? Anybody who likes ceremony here? Not a single person, right? No. What does ceremony do? You're like so excited. Can I do this? They say, no. Before you can do that, you got to do all these ceremony. Ceremony sucks the life out of you, right? And you're like, you know what, never mind. I don't think I want to even do this anymore, right? So ceremony kind of really, makes it really boring, right? Get rid of the ceremony. No more ceremony. Now what happens here? Well, now that we got rid of that, put a little arrow and come in, here's more ceremony, get rid of that. And so we got rid of all of that, and the code is still working. So now we are using what's called an anonymous function. So this anonymous function essentially is a function. I wish I can actually lower the font size, but this screen really doesn't allow me to go any smaller without you losing the sight of this. So essentially the way this is going to look like is that will be right here on the same line. That's how it's going to appear. So that's basically you're saying here is a function, but it's an anonymous function. A function is four things, right? Typically, a function has a name, it's got a parameter list, a return type, and a body of a function. Of these four things, a name, a return type, a parameter list, and a body, what is the most important thing? The body of the function, absolutely. Without the body of the function, why bother? Well, right there is the arrow. To the right of the arrow is the body of the function. Right there, we got the body of the function sitting here. That's the body of the function. Great. What about the parameter list? That's to the left of the arrow. Hey, what about the return type? That's inferred. What's the name of the function? Who cares? It works. Right? We don't care what the name is anymore. So that's an anonymous function, and he's happy with it. That's great so far, but look at this code right here. We have this particular index. Why did we even bother to create an index? The reason we created an index is the variable I is a mutable variable, which is pretty sad, isn't it? I saved the seat for you. I defended it with my life. You can ask them. They'll tell you it's true. So the whole idea here is that the variable I is actually mutable variable, and obviously you cannot use effectively final on it because it's not effectively final, it's being mutated. But what would be nice is to have really a variable that's not mutable, that is immutable, yep. So how do we do this? So here's an idea. We can say import util, Java util, stream, and I'm going to bring here an int stream.range, and I'm going to say go from a value 0 up to the value 9. So now we have a little range of values. This is new in Java 8. Then I can say for each, given a value I, and I'm going to remove all that fluff around it, and simply say, here's our executor service, and I want to use that executor service here. So all I have done in this particular case is, I've used that particular variable, and I have removed all that ceremony that was around that particular function. Let's make sure I'm doing this correct. So I have an int stream.range. That's a value 0 to 10. Then for each of the values in that range, I start with the value I, which is a value in that index. Then I say, here's a function I want to implement. And within this function, I'm calling the submit method. And then within the submit, I am closing the print line, I'm closing the submit, I'm closing that function, and that's pretty much what I'm closing here, right? There you go. So you can see how we got rid of all of that. And the way this code is going to look like, if I were to really use a reasonable font size, it's going to look like that, something like that, right? So it should be that coming through and that coming through. So that is basically how it's going to look like, right? So something like that. So that's basically the idea behind this function. It's going to look like that. So it becomes a lot easier to read, understand, because it's going to be less ceremony, less noisy code. That's how it's going to look if I were to show you at the proper font size. So that's an example of how we can refactor this code so that we don't have to go through that much kind of ceremony. So in other words, we passed runnable before, now we're passing a lambda. We were using the for loop to go through the range before, now we're using a range, so we can start converting to some of these functions, make the code easier to understand. So I'm going to make one statement, and I'm going to back up that statement through these examples. When it comes to programming in Java 8, you're not going to do anything different. You're going to do it differently. You're going to do the same things you did before, but you're going to do those things very differently than you have been doing it. You saw a piece of code that worked before. When I changed the code, what did it do? It did exactly the same. It didn't do anything different. So with Java 8, you're not going to do anything different. But we did it very differently, right? You are doing it very differently than you did before. That's going to be the theme in Java 8. You're not going to do anything different, but you're going to do it very differently. And that gives us more power on our hands because we can be more efficient with it. Let's look at one other example. I want to create a object and work through a series of values. So let's take a look at one example here. Here's a is prime. You probably saw this example in the morning where I'm going through and creating a Boolean divisible, and then I'm looping through trying to find if it's divisible. Then I perform a check in the end. This is a very imperative style of programming. Then I have a main where I'm trying to find the square root of first 100 prime numbers. And you can see in this case we're looping through and doing it. We can rewrite this in functional style very easily. And how do we go about doing this? Let's start with this first. Well, first let's run this. It says 1.41 and 23.25, right? How do we rewrite this code? Rather than so much fluff, we can simply say here, bring me a stream over here dot star, and I'm going to say number greater than 1 and int stream dot range from 2 to given number, and I'm going to say dot none match given a value I, number mod I is equal to 0. So now when you run through this, it produces the same result, but you can see it's a lot less code than we started out with. But this one is a bit more tricky. What does this do? It is doing imperative code, going through one at a time, but that's a lot of code. Let's try this a little differently. I'm going to first of all say stream dot iterate from 1 given a value plus 1. I want you to stare at this one for a little bit. What does this do? This is called an infinite stream. It starts in this case with 1, and what is the end? There is no end to this. It is infinite in size. Isn't that wonderful? Now the next question you would ask is, if it's infinite in size, where in the world would you store it? On the cloud, of course. Well, this is very smart infinite loop, infinite collection. It's infinite, but it only gives you values on demand. You probably have seen these kinds of collections, right? You go to a public office which is very busy. You walk in, there's a group of people, what do? They say, go take a token, right? You know what I'm talking about, right? So you walk up to this machine, and what does the machine have? A little paper hanging off of it. You pluck it out, what does it say? 287, right? You know what I'm talking about? You look and say, 287, that's a long wait. You sit down. Next person comes in. What do they get? 288. The next person, 289. That's an infinite series, isn't it? If you think it is not, bring a little kid with you. What does the kid do? It's like, oh, stop it. And the kid is like, cool, keeps on coming. That's an infinite series, right? Every time you request, it produces a new value. That's exactly what this does. And it is a lazy evaluation. What does that mean? This is the number generator. But the number generator here generates on demand. If you don't ask, it doesn't do any work. With me? So that laziness comes from lambda expressions, right? Great. Now that we have the laziness, then I say dot filter sample is prime. I say give me only the prime numbers from this collection. You really have to think a little differently. There's an infinite series. There's no end to it at all. But if you ever ask for a value, if you don't, nothing happens. If you ever ask for a value, then it checks, is the value prime or not? If it's prime, got more work to do. If it's not prime, toss it out. That's what filter is. So filter basically is like a coin sorter, right? You take a coin sorter, put coins over it, the smaller coins fall off, the bigger coins are held behind. That's like a filter, right? So that's or like a coffee filter, right? You take coffee filter and the coffee is held back and you get the coffee decoction, whatever you call it, comes through, right? That's exactly what you're doing here. And then once you do that, what do you do next step? Well, then you say map. Map is a transformation. So you're saying, if this input comes in, I want to transform that to produce that output. And you're saying, what is the transformation function? And it performs the transformation function on each and every element for you automatically. So in this case, I'm going to say, math square root is the function I want to perform. Then what do? Limit to 100 values. Why to 100? Because that's what the problem statement says, to 100 values. That's why we said 100, right? So here's the 100 values we want to limit to. What's the next thing to do? Well, now collect it to a list, because I want to put it in a destination of a list. Where is this list? Well, right there. We were trying to create it, remember? So let's go back here and say, here's the list where we want to put it. So it requires a few things. What about the toList function? That comes from stream.collectors.star, and that's a static function. So now that we have the toList function, we can see this and run it, and guess what it does? It says the same exact result. Make sense? Now, how does this work? If I give you this code, is this code very easy to understand? Not really, right? You're going to look at that, you're going to stare at it, you're going to ask yourselves, what is it doing? And then you look at it and say, is it less than or equal to, plus or double plus, is it plus plus or plus plus after? All those things you have to worry about, right? And what do? You run it, or you write it, and then what do? You keep checking it. You don't quite easily walk away. You turn around and look back and say, is this work going to work? Did I forget something here? Do you ever get that feeling? This is like you're walking in the mall, and you get a feeling that the guy behind you has a knife. Right? That's the way this code is, right? You're not comfortable anymore. You're kind of looking around while you're walking a little faster. That's that code, right? It doesn't leave you comfortable. And sometimes this happens to you, right? You write code, you're driving home, or you're having dinner, and suddenly you think of this code. And it's no fun after that. The rest of the family looks and says, are you okay? And you're like, yeah, I was just thinking of the code, right? That's what these kinds of code does, right? What about this code? Oh, give me a collection of values, get me only primes, find the square root, oh, just give me 100 of them, put them in a list. And end of story. Was that easy? Absolutely. So here's something to think about. A good code should read like a story, not like a puzzle. Most of the time what happens? The code we write reads like a puzzle, right? You read this code and you're like, Here's another even worse, right? You write a code like this and you give it to your colleague. What does your colleague do? Sits there and scratches the head several hours, right? And finally there's a bulb. Wow, I got it. Once the colleague gets it, what does the colleague do? Now it has a burden to return that favor to you. So the next code your colleague writes is going to be a bigger puzzle for you to solve, right? And then it's like, what do you think? You take 7 more hours. And then you say, that was really good. Wait until tomorrow when I come back to you. In the meantime, you got to release a product that doesn't work really well, right? So the code should read like a story, not like a puzzle. If you really want puzzle, go watch that thriller. There's a good news. It ends after 3 hours. This one stays with you for a very long time. Not really. I worked on this project, the code got really ugly, and guess what? I fixed it. I quit. Right? Unfortunately, when you quit, I'm retiring, what do? You go to work in some place, somebody else has quit from there to remember for the same reason, right? It doesn't help. So be careful. So we want to really write code that's easier to understand, easier to maintain. So what did we do? Well, external iterators versus internal iterators. You want to write specialized functions to really do the job. What about specialized functions? Look at what we've been doing so far. I want to loop through values. What do you normally use for that? For. I want to loop through the values, but only up to a certain number. What do you normally use? For with the if. I want to skip a few values along the way. What do you use? If and for and if and continue, right? So this is like you hear a knock on the door. You open the door and there's a guy standing there. Who are you? He says, well, you guys called that you wanted to fix the kitchen? He said, yeah, what do you have with you? And he has a hammer with him, right? You're like, yeah, I have a hammer. Well, is that enough? He takes a whack and says, I got a hammer. I don't need any sticking tools, right? You're probably going to shut the door and call the cops, right? You know what we've been doing, right? You come to work and say, I've got 4. Well, how do you do it for? Everything. That's what we've been doing, right? But what does a professional do? Walks with a little bag, ring the bell, hey, who are you? Came to fix your kitchen. And puts it on the kitchen floor, takes all these little tools, a little spanner, a screwdriver, other tools, chisels. You say, are you going to use all of that? Like, no, of course not. I'm going to use what makes sense, right? The person who uses all the tools, we call them consultant, right? So what does this person do? This person says, I'm going to only use what is necessary, right? But that's what a professional does, right? Uses the right tool for the right job. Well, that's what we did. Rather than using this while loop for everything we said, oh, here's a little filter tool, here's a little map tool, here's a limit tool, and here's my collect tool. So little tools that we combine together to solve the problem, that becomes an easy way to express it. That's exactly what we did here. So we can use function composition. That's what composing through. We use an infinite stream and a lazy evaluation. How does this evaluate lazily? It says, keep working on each and every value up to the top to bottom, rather than horizontally. So take the value, first value, 1. Hey, 1 is not a prime. Oh, that failed. Try 2. Oh, 2 is a prime. Great, find the square root. Go down. Hey, the limit says 99, not 100 now. Okay, try 3. Now limit is 98, not 100, not a 0. Keep going until the limit becomes 0. The minute the limit is 0, you're done. Collect it and you're done with the value, right? So that's a laziness baked into it. Well, I'm going to skip over this one. I'm going to go to the next one. And I'm sure we all have faced this problem before. So let's look at one example of this. Suppose you're given this wonderful problem to solve. The problem you've been given is this. Find the files in the current directory and print their names in uppercase, comma separated. Right? Very simple, right? So what do? Hey, I got an idea. I can say file current dir equals new file, and I can specify the dot. So where does that come from? That comes from java.io, right? We can specify that. Great. Current directory given to us. What should I do now? Well, now that you have a current directory, you can say file children, which is going to be an array of children, and equal to what happens? Current directory dot list files, right? Great. Then you can say if children is not equal to null, right? Then what do you do after this? Well, you could say, hey, how about doing this? I can say for string, well, actually file child in children, and then I'm going to say output child dot get name dot to uppercase, right? So we could get the file and we can print it. So there you go, that was easy. That printed all the files in uppercase. You say, yes, it did, but they're all in different lines. You want them all in one line, right? So how do you write them all in one line? That's easy. That's all in one line, right? So run it, yay. But there's nothing separating them. So what do? Well, you could try to put a little comma like this, right? So you can say comma. Well, by adding this comma, now you're printing them all comma separated. So run it. Now what's going to happen now? There's going to be a stupid comma in the end. Has anybody had that problem before? Everybody here, right? And when you ran into this problem, you said, That's kind of funny. Why is that comma in the end? And you're sitting there and looking at it, and then you come up with this bright idea. I'll come up with a string, then I'll go remove that comma from the string, right? And then you tell yourselves, wait a minute, but the string is immutable. Damn, create a string buffer instead. Then you say, what is the method to go remove that element? Oh, you can based on the index. 20 minutes later, you're still working on it, right? And all that failed attempts later, you say, there's got to be a better way to do it. And then it dawns on you, there is a better way to do it. Why didn't you think of this before? Man, this is amazing. All you have to do is for int I equal to 0. I less than children dot length, right? Is it -1? And then I plus plus. And then what happens? Well, if I is not equal to children dot length dot, is it -2? And you realize you're still about 30 minutes away from getting it done, right? Have you ever had this problem? And then you told yourselves, life sucks, right? Because that's not the way it should be, right? So such a trivial job turns into a horrible thing, right? And in the meantime, right, you're doing this. Anybody here works from home from time to time? Oh, some of us, right? Careful, careful, very careful. If you're writing that code, you got to be very careful. Because when you're writing that code, your child walks in. And the child looks at this and says, that's what you do for a living? Right? They never want to take up a profession after that, right? I mean, I go to my son and say, do you want to become a programmer? He looks at me like, are you kidding me? Right? He's like, stay away, right? I mean, that's what happens, right? Yeah. So there's got to be a better way to do that, right? How about this? Stream.off. Well, here's the children. Then we say, hey, now that we have that dot, I want to perform a map operation, file, get name, perform another map operation, string to uppercase, so we convert it to an uppercase, dot collect, joining using a comma. Now that you have all that result on your hand, go ahead and just print it for me, and I will output the value onto that. So you can see in this case, once again, functional style to the rescue. Given all the children, get me their names in uppercase, join them all together using a comma, no comma in the end, and this could be either joining them with comma, it could be a list of directories, you want to add them as a class path, so joining could be taking a class path separator, right? Makes sense, isn't it? And it reduces the amount of clutter on the code we have to write. It becomes very, very easy for us to work with the code. That makes for a very expressive code. Make sense?
I have a question.
Yes, please.
Possible to avoid that not equal to none?
Oh, that's a really good question. Is it possible to avoid the not equal to null? Remember what effective Java tells us. Effective Java says, do not return an empty collection, always return so do not return a null, instead return an empty collection. Well, they didn't listen to it, right? So they decided to give you a null. Sorry. As long as you're using a directory, it won't. However, there's a good news. You can, instead of doing this, they have enhanced the file class and the directory class. Now they give you streams from it. So you can start using streams instead of using the list files, for example. Then you can avoid the null. Good question. So look for better methods available in Java 8 and not the old interface. That's something you could try to do. Great. Now, we talked about that. But let's get to one other little example here we can look at. So the next example I want to look at here is going to be a collection of people. So I got 3 people here, 4, Mark, Bob, and Jill. Oh, Sarah and Bob are the same age, 12 years old. What am I doing here? I'm calling the sort, then I'm printing the value. Run it, you can see that the values are sorted. What do you think? What do you think of the sort method? It's a really good method, I'll invite it home for dinner, or it's evil, stay away. What do you think? Evil? Did I hear evil? How evil is it? Little evil? Friendly evil? Very evil. What does it do? What does it do that you hate it? It changes the input. What do you think of changing the input? It should be crime punishable under law, right? That's a bad thing to do, right? You give it a value and it totally messes it up. And you're like, what did you do to my collection now? What was the order I had it? Doesn't matter, keep this now, right? That's what it does, right? Completely changes this. It just takes it on, it's like, I'm going to change it. That's pretty sad. That's one problem. Another problem, look at the person class. What happened to it? It is intrusive. You have to implement the comparable interface on it, right? That's the first problem. Not only do we have to implement it, we have to write the compare to method as well. How terrible that is, right? So let's get rid of that. Now this guy doesn't work because he's unhappy, I got rid of it. Get rid of that too. So what do I do? Rule number one, never modify an input given to you, right? That's a very bad programming practice. If somebody gives you a data, treat the data with respect. Don't go modifying it. You can transform the data, but you cannot modify it, right? Now you may say, well, but then why did they do it? You got to keep something in mind. When Java was released, well, some of you may not be that old actually. When Java was released, C++ was the language that ruled the world. And C++ got to where it got, which is performance. How did it become really good in performance? By disregarding every moral value. Just like politicians, right? Hey, he's rich. Of course, don't ask how he got there. And that's what C++ did, right? Just changed everything, right? Well, but why did C++ do it? Because until that point, every single language that was O was slow. If O was slow, nobody was going to adopt it. So C++ had to cut corners and show it is possible to be fast and furious. It can fail really fast too, but that's what it did. This I call as a politics of languages. We have to live in this world with politics, right? It would be nice not to, but we do. You cannot be an idealistic language and say, I'll be perfect. They say, yeah, perfect, sit in a corner, nobody cares, right? That's a problem. So as a result, they had to fight those three through. When Java was introduced, they could not compromise on performance. Because it was slower than C++, and it was, unfortunately, at that time, they couldn't make it any slower. So they had to cut corners too. So a decision that was done 20 years ago, we know today is not a good decision. This is legacy we have to carry with us. So methods like this are written in a different time. They were written for a different reason. And all we have to do is sympathize with it and say, thank you, but we can move on from there, right? And so what can we do differently? Well, what we can do differently is, here's the original list. What I'm going to do here instead is I'm going to say, let's go ahead and write this a little differently. I'm going to say public, static, void, print sorted, and in this case I'm going to say list of person, we'll call it people, and I'm going to say comparator on person comparator. Now that I have this, I'm going to write a little bit of code to use this comparator. So I'm going to say java.util.comparator, but I'm also going to bring in a static method from the comparator. This is one thing in Java 8, interfaces can now have static methods, and it can also have default methods, implementations of methods. So now I'm going to come back to this code. What am I going to do in this code? I'm going to say people.stream.sorted based on the comparator for each system.out print line. So what do I do with this code now? Notice what I'm going to do here. I'm going to simply say print sorted people, comma, comparing, isn't that beautiful? Comparing based on what? Comparing person by get name. Very fluent syntax, isn't it? So comparing creates a comparator, and once it creates a comparator, we're asking you to pass that comparator to this function. Happy with that so far? Let's try this one more time. When you ran this, it was sorted based on the name. Get age. Now what happens? Sorted based on the age. Pretty nice, isn't it? So rather than the name sorting, you got an age sorting. You look at this and say, okay, this is great, but there's somebody here very unhappy. Who is that? Bob, of course. Bob says, not fair. I am 12 years old. I should be first. If Bob was a perfect gentleman, he would know better. Ladies first. But come on, he's 12 years old. He doesn't know this stuff, right? Give him some more time to grow up. So what do? All right, fair enough. Dot, then comparing person, get name. Bob is very happy. So you can start chaining these even further, right? So A, not intrusive. B, you didn't modify the input. C, you're able to nicely, fluently write it. So this is another power we have in Java 8. We can look at these kinds of comparators and start chaining them together very powerfully, right? So that becomes really, really nice. One last transformation I want to perform. Well, there's a bit of a problem here. The problem here is I have a class called resource. Notice in this case, this class called resource, constructor says creating, right there. Op1 and op2 are simply saying those, and I got a finalize method, which is saying external copy. Then I have a main. I create a resource called op1 and op2, so I'm going to run this code. It created the object called op1 and op2. Did it clean it up? No, it did not clean up. Hey, did I call the finalize method incorrectly? No, that's spelled correctly. So why is it not cleaning up the resource?
During the garbage collection.
What, say that again?
It might be executed during the garbage collection when it happens.
So why didn't it do it?
Can't force the garbage collection.
You cannot force a garbage collection. When does a garbage collection get invoked? When it's thirsty for memory, right? But this guy says, I got a memory. I don't have to run it. This is an example of two different concepts being mixed together, right? I want to free up memory. No worries, we'll do that for you. But I want to free up resource. I had a client who ran into a problem with this. They said, come on over, Venkat, do a code review for us. And while you do a code review, maybe you can help us to fix this problem. And the manager said that. I said, what's the problem? And the manager said, go ask the programmers, they'll explain it to you. And I went asking the programmers. One programmer nailed it. The programmer said, our code works fine most of the time. I said, that's great. Can you tell me when it doesn't work? Oh yeah, it doesn't work between 7:15 and 9 in the morning. I said, wow, really, every day? He said, no, Monday through Friday. Works fine on Saturday and Sunday. I was like, what would that be? Well, it turned out it's an application on a portal system, and guess what happens between 9:15 and 7:15 and 9 in the morning? People come to work, they log on, whether they like it or not, they end up using the system, right? Well, as I was doing the code review, I found what they were doing. In the constructor, they make the database request to open a connection. And with the finalize method, they were releasing the connection. Well, guess what? In theory, it's a good idea, right? But because there was a lot of memory, the garbage collector never kicked in, so it never had a reason to call the finalize method. In the meantime, the constructor was choking up, but that exception was not being propagated properly, and guess what? They didn't know what was going on. Once I got a hunch of what was going on, I said, hey, why don't you go take a look at how many database connections you have? And this guy runs a little profile. Oh, we got a lot of that running over here. Yeah, that seems like a problem, right? And all I did was I said close. I changed the finalize to close, that's all I did. Then I came quietly here, and I said, when they're done with it, I said resource.close, that is all I did to begin with. Well, guess what? It did the cleanup, isn't it? Well, we ran this application, and I said, how's it going? And the guy said, yep, the problem is gone now. Yeah, this is awesome. It doesn't fail anymore. We solved that 7:15 to 9 a.m. in the morning problem, right? Well, it was kind of funny, because that afternoon the boss comes back from work, from lunch. He was curious, like everybody should be curious. He said, how's it going? And the team was very eager to report. Oh, remember the problem we've been having? Well, good news, we fixed it. He said, really, that's great. What did you guys do? And one of the guys said, oh, Venkat asked us to add this one line of code. We added, and the problem is gone. And the boss said, really, what else did he do? So that's it. We added this one line, the problem is gone. And there's a pause, and then I heard him say, well, if you only added one line of code, do we still need to pay him? Yeah, I did send them an invoice, definitely. Well, unfortunately, though, this code is pretty... It's possible the close may never get called. How is that possible? Exception, I heard. Another reason. You're right. It's exception. What else?
If it's a long thread.
No, there's no long-running thread. Well, if it's long-running thread, let it keep running long. I may forget to call it.
Error.
I may forget to call close, right? If I never call close, it's never going to be called. So I could forget to call it. That's one problem, right? Second, there may be an exception. Two problems. Well, which problem do we want to solve first? Forgetfulness or the exception? Exception, okay. So we can say try, and now what happens? Finally, and the close can be in here. Did we solve the exception problem? Yes. Now, what about the forgetfulness problem? Is that gone or is it worse? Is it gone or is it worse? It's worse. Why is it worse? Because now you will forget to call close and the finally. Right? It's only worse, right? If you are going to forget to call close, what makes you so smart to remember to call try and finally and say, you know what, if it's only close, I'll forget it, but try and finally, I would never forget it, right? That's even more broken, right, than it was before. What do we do? But it is one other problem. So the forgetfulness became worse. There's one other problem, right? Would you agree the code has become more smelly now? Right? It's a little smelly, right? You got to put a try, you got to put a finally. That's more code to write. Would you agree? So not only you may forget it, if you forget it, that's bad. If you remember it, it's even bad. So what can we do? Maybe we'll fix one of those two problems. Let's fix the smell problem for a minute. So here is a really good news. I can reduce the smell. I can remove the finally. When I remove the finally, I can then say try, and I can put this right here in here. There's a name for it. This is a Java 7 feature called ARM, which stands for Automatic Resource Management. But of course, for this to work, you got to go to the class resource, and you got to implement auto-closable. So now that I put auto-closable there, if I run this code, notice how beautifully it performs a cleanup for us. We don't have to write the finally block. Would you agree that it's less smelly than it was before? Right? Less noise, that's awesome, great, isn't it? Awesome, that's wonderful. However, there is still one problem. What if I forgot to put the try? I forgot to put the try. Will the compiler look at this and say, uh-oh, this is auto-closable, but you did not put the try. Hey, Venkat, wake up. You should really do this. Do you think the compiler is going to tell you that? I'll give you a clue. Yes or no? What is it? No. When you run this, what happens? It didn't say anything at all. But I know you're not surprised about this because you know the answer already. You should never trust a feature with the word management in its name, right? So that didn't work after all, right? So wouldn't it be nice if this is done for us and we don't have to say, oh my God, I forgot it, right? That would be really nice. So forget this auto-closable business. Let's try to implement it in a way we will never ever forget to do this. So here's the resource.close. And of course, if you run this, it's closing it, but you know this is broken because we're not doing the finally block. How do we fix it? The very first thing we're going to do to fix this is we're going to go back to this code and we're going to make the close method private. Now the programmer comes along, the compiler says on line number 15, hey, you cannot call close. Programmer says, okay, no problem. Sadly, that didn't fix the problem. Let's go back to the constructor and make the constructor private. Now the programmer gets an error on line number 12. And the programmer says, what now? I can't even create an object of this class. How in the world would I use this? Now we got the programmer channeled in one way of using this. So we will say here, public static void use, and right there is a use method. Now if resource is a problem, we got two people who can handle it. The programmer can forget it, or the person writing the class can proactively handle it. Would you agree? Which is better? The second one. Because if the resource is important, the person writing the class should really say, hey, this is important, otherwise bad things happen, I'm going to take care of it, right? So as a person writing this class, I'm going to say try, finally, and I'm going to say resource.close. Hey, but what is the resource after all? Well, the resource is going to be a resource. I'm creating resource equals new resource. And now that I created a resource, I'm going to say over here, a block dot accept the resource. So now that I've called the block, what in the world is the block? The block comes from Java 8's function.consumer. That's what we're going to use here. So I'm going to say in the use method, consumer resource, and I'm going to call this one as block. So now you can see we created a resource. We're sending it to this block's accept method. Whether it comes back dead or alive in the finally block, we're going to close it. So now we go back to this code and say resource.use. Given a resource, I want you to use that resource for doing the job. So now you can see when we run this code, it cleans it up automatically for us. You don't have to say, oops, the programmer forgot to write it. The programmer cannot forget to write it because use is the only way they can get access to the object. So you call the use method. Before you ever get to the object, it's been initialized properly. You use the object. When you're done and return, it gains control and cleans it up. So this is called the execute around method pattern. This pattern was created way back in time during the Smalltalk days. But now that we have availability of Lambda expressions in Java, we can start using these kinds of patterns now to program, which becomes pretty powerful. So what you saw here is dealing with the problem. We went through the route. We discussed about different solutions, including ARM, and finally we said we can use the execute around method pattern to solve the problem. So in conclusion, the moral of the story is you're not going to do anything different in Java 8, but you're going to do it differently in Java 8. So it's a paradigm shift. We have to start changing the way we code. Well, sure, Java has new syntax. Sure, Java has a few new functions. But I'll tell you the biggest change in Java 8. The biggest change in Java 8 is in the minds of the programmers. We have to change the way we program Java, and that's the learning curve we have to go through. But But once we do, we got a lot of power, and we can benefit from a better style of programming and reap all the benefits, some of which we talked about here. I hope you found that useful. Thank you.